This is a story about the H20, Nvidia's export control chip that's reshaping global AI. The Nvidia H20 chip represents one of the most fascinating case studies in modern technology, a deliberately neutered version of the world's most powerful AI chip, engineered specifically to comply with US export restrictions while still serving China's massive AI market. Despite being 85% slower in raw compute power than the flagship H100, the H20 generated over 12 billion in revenue for Nvidia in 2024 and sold more than 1 million units to Chinese companies. More surprisingly, this compliance chip actually outperforms the unrestricted H100 in certain AI reference tasks, creating an unexpected competitive advantage that has reshaped a global AI development strategy. The H20's story reveals how export controls intended to limit China's AI capabilities have instead accelerated Chinese innovation, driven massive stockpiling of restricted technology, and inadvertently created new technical solutions that benefit specific AI workloads. This analysis examines the technical architecture, market impact, and strategic implications of what may be the most consequential AI chip most people have never heard of. So let's get into a little bit of the technical architecture and some of the trade-offs. The H20's design represents a masterclass in compliance engineering. Nvidia took their flagship H100, a chip containing 80 billion transistors on 814 millimeter square die, and strategically disabled cores until it met export control thresholds. The result is a chip with 78 streaming multiprocessors compared to H100's 132, and delivering just 296 teraflops versus the H100's 1979 teraflops peak performance. However, Nvidia made a crucial architectural decision that would prove unexpectedly beneficial. While gutting compute performance, they actually increased memory. They increased the memory capacity to 96 gigabytes versus the 80 gigs on standard H100s. And it boosted the memory bandwidth to 4 terabytes per second versus the 3.4 terabytes per second that was on the H100. This created what engineers described as a memory-rich, compute-constrained architecture, the exact opposite of typical GPU design philosophies. The power profile tells the efficiency story. At 400 watts, the H20 consumes 43% less power than the 700 watt H100, making it surprisingly attractive for large-scale deployments where power and cooling costs matter. When measured by memory bandwidth per watt, the H20 delivers 10 gigabytes per second per watt compared to H100's 4.29 gigabytes per second per watt, more than doubling efficiency in this crucial metric. This unusual architecture created an unexpected performance inversion. While the H100 dominates training workloads by 6.68 times, the H20 actually delivers 20% better performance than H100 for large language model inference. The reason lies in how modern AI models work. Inference is often memory bound rather than compute bound, making the H20's higher memory capacity and bandwidth more valuable than raw processing power. The H20 exists because of sophisticated regulatory framework designed to limit China's access to advanced AI capabilities. The US Bureau of Industry and Security implemented controls in October of 2022, targeting chips with total processing performance above 4800, and later revised this to 1600 for data center applications. The regulations also introduced a performance density threshold of 5.92 teraflops per millimeter square, explicitly targeting high-end AI accelerators. Now, NVIDIA's response was remarkable in its precision. The H20 delivers 2.9 teraflops per millimeter squared, exactly 51% below the regulatory threshold, and achieves 296 teraflops total performance, remaining 81% under the limit. This engineering approach built in significant safety margins to avoid future regulatory changes while maximizing performance within legal boundaries. The timeline of controls reveals an escalating technology conflict. Initially, in October of 2022, restrictions targeted flagships H100 and A100 chips, prompting Nvidia to develop the H800 with reduced interconnect bandwidth. When regulators closed this loophole in October of 2023 by removing interconnect restrictions and tightening performance thresholds, Nvidia responded within weeks with the H20 design. Most recently, this April of 2025, restrictions targeted even the H20, though the Trump administration reversed this decision just a couple weeks ago here in July of 2025. Chinese companies demonstrated remarkable strategic foresight throughout this process. Major tech firms, including ByteDance, Alibaba, and Tencent, collectively ordered over 1.3 million H20 chips worth more than 16 billion in Q1 of 2025 alone, essentially stockpiling several years worth of inventory before potential further restrictions. This buying surge made ByteDance Nvidia's largest Asian customer and drove H20 demand beyond all initial projections. So rather than crippling Chinese AI development, export controls have actually catalyzed an aggressive push toward technological independence. The numbers tell a striking story. While Nvidia shipped 1 million H20 chips to China in 2024, domestic competitor Huawei managed only 200,000 Ascend 910B units. However, Huawei's next generation 910C chip delivers 2.6 times the computational performance of the H20, albeit with 20% less memory bandwidth. The market dynamics are shifting rapidly. Morgan Stanley projects that Chinese GPU makers could capture 70% of the domestic market by 2027, up from 30% in 2024, representing potential sales of 287 billion yuan. China unveiled a 344 billion yuan investment fund in May of 2025, the third such fund in a decade, specifically targeting semiconductor development. Major Chinese tech companies have pursued distinct adoption strategies. ByteDance became Nvidia's largest chip customer while simultaneously investing in domestic alternatives and international manufacturing partnerships in Malaysia. Alibaba increased capital expenditure by 123% year over year to 23 billion yuan while developing its own Hongguang 800 AI inference chip. And Tencent boosted infrastructure spending by 176% and is beta testing Chinese AI models on WeChat's billion user platform. Perhaps most significantly, the emergence of DeepSeek's cost-effective AI models has demonstrated that Chinese companies can achieve competitive results with constrained hardware. DeepSeek's approach costs 14 cents per 2 million Chinese characters compared to $5 for GPT-4, proving that algorithmic efficiency can partially compensate for hardware limitations. The H20 phenomenon illustrates how technology export controls can produce unintended consequences that ultimately benefit targeted nations. Rather than preventing Chinese AI advancement, restrictions have accelerated domestic innovation while creating new technical solutions that sometimes outperform unrestricted alternatives. Nvidia's business strategy has adapted to this reality with remarkable success. Despite losing access to flagship products, China still represents 13% of Nvidia's revenue in 2024, generating an estimated 12 to 15 billion from the H20 sales alone. However, the company also absorbed a 5.5 billion quarterly charge when H20 sales were restricted in April of 2025, demonstrating the financial volatility of operating in this regulatory environment. The strategic landscape is bifurcating along technological lines. Chinese companies are developing a complete domestic AI ecosystem encompassing chips, models, and applications that may eventually exclude foreign competitors. This China for China approach is already showing 30% year-over-year revenue growth for domestic suppliers as international companies withdraw or face restrictions. Manufacturing capacity reveals a long-term challenge. While Chinese companies significantly lag in advanced chip production, with yield rates improving from 20 to 40%, but still below global standards of 60% plus, they are rapidly building capability in legacy nodes and alternative approaches. China is expected to control 39% of global legacy chip capacity by 2027, potentially reducing dependence on advanced foreign technology. Real-world deployment data changes conventional assumptions about AI chip requirements. While the H20's 41% fewer cores severely limit training performance, its memory-centric architecture excels in the inference-heavy workloads that increasingly dominate AI applications. Major Chinese companies report that the H20's 25% lower token-to-token latency and ability to run Llama 70 billion models on a single chip versus requiring two H100s creates significant operational advantages. Benchmark testing confirms this counterintuitive performance profile. In Geekbench 6 OpenCL tests, the H20 scores 248,992 points, compared the H100's 280,000 to 350,000 points, a 28% performance gap that narrows significantly in memory-bound inference tasks. The H20's 96 gigabytes memory capacity with 4 terabytes per second bandwidth creates a memory to compute ratio 9 times higher than the H100's optimized for exactly the workloads that define modern AI deployment. Power efficiency calculations reveal additional advantages. At 0.74 teraflops per watt, the H20's raw compute efficiency appears more compared to the H100's 2.83 teraflops per watt. However, when measured by memory operations per watt, increasingly the limiting factor in AI inference, the H20 delivers 2.3 times better efficiency, making it attractive for large-scale cloud deployments. Training performance tells a different story. Companies using H20 clusters report needing 4 to 9 months to train large models than would require 2 months on equivalent H100 systems. This training penalty has driven some Chinese companies to focus more heavily on inference optimization and model efficiency rather than on scaling to larger parameter counts. The H20's market success demonstrates both the effectiveness and limitations of technology export controls, while successfully limiting Chinese access to cutting-edge training capabilities. The controls have simultaneously created massive economic opportunities for domestic Chinese competitors and accelerated technological independence. Nvidia faces a complex strategic calculus. The company generated substantial revenue from compliance chips while maintaining technological leadership. But recent policy volatility creates uncertainty about future market access. The $16 billion in Chinese H20 orders represents roughly 25% of Nvidia's quarterly revenue, making this market strategically critical despite regulatory risk. Chinese domestic chip companies have become the primary beneficiaries of export restrictions. Cambricon Technologies achieved its first ever quarterly profit in late 2024, with stock prices surging 470% over the past year. Huawei's Ascend series, despite production challenges, is approaching competitive performance levels while building a complete software ecosystem that could eventually eliminate dependence on CUDA. The global supply chain is fragmenting along geopolitical lines. Advanced chip production remains concentrated in Taiwan, South Korea, and planned US facilities, while China dominates legacy node production and develops alternative approaches. This bifurcation creates risk for both sides of US companies, for both sides. One, US companies lose access to the world's largest AI market, while Chinese companies face technological constraints that may limit their global competitiveness. The Nvidia H20 story illustrates how technology export controls can achieve tactical objectives while producing strategic consequences that may ultimately benefit targeted nations. By restricting Chinese access to advanced AI hardware, the controls have accelerated domestic innovation, created new technical solutions optimized for constrained resources, and driven massive investment in technological independence. The H20's unexpected success in inference workloads, outperforming the unrestricted H100 despite 85% lower training performance, demonstrate how technological constraints can drive innovation in unexpected directions. Chinese companies have leveraged these architectural advantages to develop more efficient AI models and deployment strategies that may prove competitively advantageous regardless of hardware restrictions. Looking forward, the global AI industry is likely to remain divided between competing technological ecosystems. US and allied nations will continue advanced cutting-edge training capabilities, while China develops alternative approaches optimized for different hardware constraints. This fragmentation may ultimately reduce global innovation efficiency while creating redundant technological development paths. The H20 phenomenon suggests that technology export controls, while effective in limiting access to specific capabilities, cannot prevent determined nations from developing alternative solutions. In some cases, these alternatives may prove superior for specific applications, creating competitive advantages that outlast the original restrictions. As AI continues evolving towards inference-heavy applications, the H20's memory-centric architecture may represent not just a compliance workaround, but a glimpse of future AI hardware optimization strategies that benefit users worldwide.